This video is about indices, what they are, how we use them, and specifically how they're different to multiplication. Alright, let's say we've got a situation where I want to do 5 plus 5 plus 5 plus 5. A very quick and easy to write that, quick and easy way to write that would be 5 times 4. So 4 lots of 5 multiplied by 4, 5 times 4, which is of course 20. Now, if I wanted to do 5 times 5 times 5 times 5, this is where indices come in. We can say that this is 5 to the power of 4. So what we say is that 5 is the base and 4 is the power. So 5 to the power of 4 is going to be a much different number. If we go into a calculator, we can do the number 5 to the power, so this button here, let's put a power on the number, to the power of 4. And it gets us 625. So if we want to do 5 multiplied by itself 4 times, as opposed to 5 added to itself 4 times, that's what powers are. So it's very important to note that 5 times 4 is not the same thing as 5 to the power of 4. They are much different things, but both achieve the same goal of making it much easier to write. All right, let's have a quick look at a multiplication problem, just so we can tell the difference. If I've got Sana, Momo, and Mina all having $10 each, and Gio has $40, how much do they have in total? So one way we could write that is 40 plus 10 plus 10 plus 10. But obviously there's a quicker way to write those three tens in that we can just say that it's 40 plus 10 times 3. Now we still have to do 10 plus 10 plus 10 before we can add it to the 40. We can't do 40 plus 10 and then multiply it by 3 because of the order of operations. But what we'll get is 40 plus 30, which is 70. All right, let's look at an example for indices now. If we've got 5 bacteria in a pond and every hour the bacteria doubles for 3 hours, we're starting with 5 bacteria and then we want to double it 3 times. So we're taking the 5, we're times it by 2, by 2, by 2. So the short way of writing this using indices is going to be 5 times 2 to the power of 3, or the other way to say this would actually be 5 times 2 cubed. So just a quick side note here, if you ever have a number to the power of 2 or to the power of 3, we have special names for these. 5 to the power of 2 can also be said as 5 squared, and 5 to the power of 3 can be said as 5 cubed. In fact, they are so common that on the calculator, you don't even need to use this power button here to put the power of 2 and power of 3. We actually have these two buttons here, which do the power of 2 and the power of 3. If you look at the other calculator, we're going to be looking at these two buttons here for the power of 2 and power of 3. This one here does all the other powers. Now, if we actually want to know what this equals, we could do 2 cubed on the calculator, but we're just going to do 5 times whatever 2 times 2 times 2 is, which is of course 8. So this equals 40. So again, because we're multiplying by 2 3 times, we did 2 with a power of 3 on it, or 2 cubed. Another multiplication example. Let's say we've got a mathematics teacher that wants to buy $2 chocolate bars for each of their students. They have 120 students total. How much is that going to cost? Well, we could do 2 plus 2 plus 2 plus 2 and sit here for an hour writing plus 2s. Or we could just say that we've got the number 2 multiplied by 120. Much quicker to write and very easy to work out. So the point of multiplication is just to compress that down. We don't want to have to write 2 plus 2 plus 2 plus 2 120 times. So we just do 120 multiplied by 2, 120 times 2, 120, lots of 2. Now let's look at another example of where we could use indices. Let's say we wanted to write the number 100,000. Now if you guys are used to multiplying by 10, what we could say is that this is the same thing as 10 times 10 times 10 times 10 times 10. Because if you multiply by 10, it essentially just adds a 0 on the end. So if we want to put 5 zeros on a number, we can just multiply by 10 5 times. But again, there's an even quicker way to write that, which is 10 to the power of 5. Now, what we use this for is if we have really large numbers like the one down here, the number of stars in the observable universe, which is 2 sextillion, that number there is the number 2 with 21 zeros on the end of it. So what we can do is we can say, look, I've got the number 2, and I'll put on 1 0, another 0, another 0, and so on and so forth. I want to put on 21 zeros on the end of that number. In fact, if you're using a calculator, if you were to type in this number with all 21 zeros, it's too long to fit on the calculator, but even the calculator will use this notation where they say, look, 10 to the power 21, chuck an extra 21 zeros on the end of this number to get the actual answer. So powers are very useful in the same way that multiplication is very useful in being able to write really long math sentences in a very short amount of space. As long as you remember the difference between multiplication and indices, you should run into no issues. Again, addition multiple times is where we use multiplication. Multiplication a bunch of times is where we use powers.